let's do the material for today. And let's start with the lecture. So what's the plan is to finish objects. So that's what we're going to do today. And in the last, then we're going to have 3 more lectures in the semester. And then the last lecture is going to be your last test. In this, so today we're going to finish object. In the 3 more lectures that we have, we're going to do recursion. In fact, we are going to finish objects today, maybe according to previous lecture, about 30 minutes before the end. And in these 30 minutes, I would like to revisit something about variables, something that is very important to understand if we are to have any hope of understanding recursion. Something that is basically necessary to understand in order to understand recursion. All right, so let's first finish off what I wanted to teach about objects. So for that, I'm going to have a different example. In fact, I believe it's an example from your textbook. So I'm starting with something that you actually know. So what you see right now on the screen is a class animal. And in this class, there's nothing new. So I'm just going to recap quickly what is inside of this class, and then we're going to see a new concept. All right, so suppose that you have tons of data that you have to analyze, data about animals. And for some reason, or in fact, for simplicity, let's say there are only 2 pieces of data that are given about these animals in this collection that you have to analyze, and which is the species of the animal and what type of sounds they make. Let's say what type of language they speak. All right. So if you're going to analyze this data, and since it would make sense to make a class animal to be able to create objects of type animal. And as I said, these objects would have 2 pieces of data. In other words, 2 data attributes. One is a spec. So each object would have 2 variable specs for species and one for the language. And then you, just like we've seen in the last class, you may have some methods that are available to that class. For example, you can make a particular object speak or make sounds and so on. We have seen, as you can see here, we have an REPR function, an STR function, such that when we create objects of type animal, then if we do print and then a variable name, or we have enter variable name in the shell, we get a reasonable representation of that object rather than just an address of the object. So that's what we had. This concept we learned in the last class. So let's just see an example of a use of this object before we look at a new concept. So for example, we can create, so we know already if I want to create an object of this type, I should call a constructor, and you call a constructor by using the same name as the name of the class. We have learned that what a constructor does is actually runs an init function. And this init function needs 2 pieces of data, which is species and animal. So let's say species is dog for our first object, and language is bark. Okay, and we want to store this object, or rather we want to have a variable that takes a variable that gives us an access to this object. All right, so Snoopy dot spec is a dog, Snoopy dot lang is a bark. We have access to some of these modules, so let's see what the first one does. Snoopy dot print info. This is not a very useful one. I just put it there to demonstrate something about what we're going to do next. Then Snoopy speak, that's the next method we have, and it prints I'm a dog and I bark. We have seen that REPR helps us have a nice representation of the objects, which basically convention is that it looks like a constructor that we use to create the object. And if we do print, in this case, It just prints whatever whatever we put in the str function. Okay, so that's, and we can see that, you know, the Snoopy variable refers to an object of type animal. Okay, so let's say we are writing, we want to analyze the data, but then once we look at this data, and we realize that majority is, let's say, about birds. And not only this majority about the birds, but that for birds, we have an extra piece of information, and it's a length of their beak. I don't know. I think I invented that one. I don't think that's in your textbook, but maybe it is. I can't remember anymore. So then you figure out, okay, I should actually, given how many of these, let's say my data set that I'm gonna first make my classes, and then I'm gonna program to analyze the data and collect all the data that I have about these animals. But then I realized, okay, because most of them are birds, and I have this extra piece of information about birds, I might as well have a different class. I might as well have a separate class for birds. Okay, all right, so let's do that. So we can start as before. I can do class birds. Do I have birds or bird? Bird. Okay, and as we have done with, and now we can start coding the class. But suppose that you already coded this animal class, and suppose that we even have many more methods than what I have here. I just put few of them here. Suppose you coded already a lot, and not only that you coded a lot, but basically that lots of the methods that you already coded, they can be reused in the bird. So suppose they're exactly the same as in the bird class, as what you want to do with your bird's information. Okay, so you can say, okay, just copy paste it, right? You can say, all right, this is all going to be, most of it is going to be the same or something. You can just copy paste this into your bird class. Okay, but why do that? Right now, there is a mechanism to basically inherit, this is called inheritance. So if you have two classes that in your opinion are so similar, that in one you can use much of the work that is done already in the other, you can tell Python, I want my object class, I want my class to inherit everything from this other class, meaning all the methods from the other class and all the data from the other class. Like, let's say if you had a class variable. Okay, how do you do? What's the syntax? It's super simple in Python. You just open parentheses, close parentheses after the name of your class. And inside of the parentheses, you add the name of the class from which you want to inherit things. Okay, so to demonstrate that you really inherited everything, I'm not going to even put anything inside of this class for the beginning. Okay, so let's see what happens. All right, as before, I have access, we can create objects of type animal. There's no surprise there. But let me now create an object of type bird. All right, so I'm going to create a bird. I want to say, I want to say what type of animal it is. It's a bird. What type of language it speaks, or sound it makes. Let's say it's chirp. Okay. And I'm going to create a variable that refers to that object. Okay, you may wonder what's going to happen now, because when we did, I don't know if you remember, when we did this class point in lecture 1, these were the first 2 lines that we wrote about when we, in our first lecture on objects, our first 2 lines of code we wrote was this. And we were able to create already a point by just doing that. Okay, empty object with no pieces of data, but this worked, it didn't crash. But if we had code like this and we said, I want 2 or 3, this crashed because nobody coded in a function that would capture these 2 pieces of data. Okay, so when we go here, we're sending these 2 pieces of data, and our bird class doesn't have any code of its own, but this doesn't crash. Why? This is it. So it's due to inheritance. So let me explain how it works. And actually the same explanation works for why it's going to, for this finally explain to us, why did this work when we did, why this didn't crash when we did it in our first lecture. Okay, so what did we learn so far is that if you call a constructor, then Python is aware that there is a, so you're calling a function here called bird. Python is aware that there is a class called bird. And what did we say when you call a constructor? That Python always executes init class. Okay, it looks, so not init class, init method, init function. Okay, so Python, so here we're about to create an object of type bird. So what does Python do? It goes to, and this is a constructor. So it says she wants to run a constructor for the bird, from bird class in order to create object of type bird. So what Python does, it goes to bird class and looks for init function. And in this case, it doesn't find it. Whenever it doesn't find a function inside of the current class, it always goes to a parent and looks for a function with that name in the parent. So it doesn't find an init. So this is a constructor. It knows this is a constructor. It doesn't wants to run init function, doesn't find init function in bird class. So it goes to a parent class. What is the parent of a bird class? The parent of a bird class, you find it inside of the parentheses. It's an animal. So it goes next to animal class, looks there for init function. If it finds it, it runs it, and that's it. In this case, it finds it, so it runs actually this code. So that's why there's no problem that we are sending these two pieces of data to init function, because actually this init function expects exactly two pieces of data, and we send it, and it creates a spec and a lang and assigns it to this variable. So this init function runs, okay, because we inherited it from our parent. Okay, so let's see, tweety.spec is a bird, tweety.lang is a chirp. If you ask Python what type of object is Tweety, it tells you Tweety, it refers to an object of type bird. If you do the same for Snoopy, it tells you that Snoopy refers to an object of type animal. Okay. So, so now, actually, let's go back to what we did in that class one. Okay, so this is what we executed. Okay, this line here, and we were able to do point like this, and it did not crash. So let's now recap. What does Python do? Python realizes she's calling a function called point, and there is actually a class of that name. Therefore, she wants to call a constructor from class point. So she wants to run init function from class point. It goes to class point and looks for init function and doesn't find it. What does Python do next? It goes to a parent. But you can say, wait a minute, there is no parent class from point class. Well, object, that Python has a generic object class, okay? And all the objects inherit from this class. So the syntax is the same. And in fact, in the previous version of Python, this was the syntax for creating the classes. You would have to say that you inherit everything from the Python's generic object class. But the syntax still works, but somehow there's really no point of adding this, since everybody inherits from Python generic object class. Somehow that cumbersome part of syntax was removed, but you still inherit everything from the, I'll get to JSON. You still inherit everything from Python's object class. So now that you know this, so what happens when we do this and why this didn't crash? The reason is that, so we can repeat this line. Again, Python goes to point class, looks for init function. It doesn't find it there, goes to a parent and looks in the parent for init class. And it finds it there, runs it, and that Python generic class just creates an empty object. It literally just reserves a slot in a memory and returns you an address of that. Okay, so you say, okay, how do I know what is available in Python generic in Python's generic object class? Well, we know how to do this. You just do dir object, and you see what is there. So Python didn't find any function in the point. It goes here into Python generic object class, and let's look for it, and that's where you find init. Okay, so it runs Python generic class init function, right? And that one just creates an empty object, returns you an address of an empty object. Okay, and in the case of this bird, we have seen that Python goes to animal class, to a parent. It finds an init class there and it runs it. And if it didn't find it in the parent, then it just goes to a grandparent, right? It goes to a parent of the animal, which is an object class. And finally, if it didn't find an init in object class, which it did, because it is, it would crash, right? So it goes to parent, to grandparent until it gets to object class. If it doesn't find some function that you're trying to run there, then only it's going to crash. That's what we have already seen. Remember in the last class when we did len for a deck method, for the deck class, when we had a deck and we wanted to do len of d. Okay, that's before we coded it. Python looked for len function in a class deck. Didn't find it there, goes to a parent class of the deck, which is actually object because we didn't specify anything. And then it goes here and it doesn't find len function. Then it crashed, right? So unlike equal, when we did in the first class, when we compared two objects of type point before we coded it ourselves, it didn't give us what we want. It was just comparing addresses, but it didn't crash. That's because even though in class point, Python didn't find underscore underscore eq underscore underscore, it then went to an Python's generic object class. It found that function here and it runs generic equal function. And that one just compares addresses stored in the two variables. Okay, so let's go back to what we're trying to do. So just to demonstrate, again, let me create again that we had a tweet. Let's create again this object. All right. Not only you have access, so obviously we inherited init function from animal class, but in fact you have access to all of these from your parents. So for example, you can do tweety.print info, even though the function is not in your class. It's going to work because Python is going to look first for this method inside of a bird class because it knows that tweety is an object of type bird. It doesn't find this method inside of that class. So then it goes to a parent class. Parent is an animal class. It goes to animal class, looks for print info function. It finds it and it runs it. So it prints what species and a language of the object. And we know that this is tweety.spec is bird and tweety.lang is chirp. Okay, so that means all of this you have access to. So the idea is that you only code the things that are different. Okay, so what did we say is different? So we said that when we are creating these objects of type bird, I would like, in addition to having it tell me the species are bird and that the language is chirp, I would like to have the length of a beak of particular data point for a bird. Okay. So I want now my objects of type bird not to have 3 pieces of data, but actually not to have 2 pieces of data, but in fact to have 3 pieces of data. Okay, so that means when we are creating objects of type bird, I should add 3 pieces of data. It should have 3 variables, 3 pieces of data. Okay, you can say, okay, why don't we just recode the init function? Okay, so in addition to, so my init function for the bird class should have beak length. In addition, should have a parameter to capture the beak length. Let's say it's in centimeters. So a user may try to do something. So let's try before I run this, and I didn't even finish coding it. Right now, if I try, I can say, okay, let's say this bird, the beak length is, I don't know, the beak length is 2.5 centimeters. Okay, so if I try this, it's gonna crash because this init function needs 2 pieces of data. Because it's the one from the parent that is run. Okay, so here now I need 3 parameters, a beak length, species, and language. And we just assign whatever self dot beak length is equal to whatever data the user gives us for this. Okay, so now we have a new init function for bird. So let's see if we have to run this code and see if that fixed the problem. And now indeed it worked. So Tweety dot beak length is 2.5, Tweety dot spec is bird, and Tweety dot lang is chirp. Okay, so that worked. We still have access to these other things, like I can still do what is it, Tweety dot print info, and that works. So what happened here? So when we run again, I just recap. This thing that I highlighted is a constructor. It wants to create an object of type bird. Python knows that there is a class with that name, goes to that class, looks for init function, finds it, and it runs it there. Doesn't look anywhere else. When we were running this print info function, Python knows Tweety is an object of type bird. It goes to that class. It looks for the print info method. It doesn't find it here. Then it goes to the parent, who is the parent animal class. Goes to animal class, looks for print info method, finds it there, and runs it. Okay. If it didn't exist there, Python would then go to a parent of an animal. Parent of an animal class is Python generic object class. It would look for print info there. It wouldn't find it, and it would crash. Okay, so that's how it works. I'm repeating the same information. Let's go back to where we were. Okay, so we have this init function. But suppose, imagine you already coded this init function, and it was actually a lot of work and a lot of code, not in our example. And we would now, just for adding this one line here, I have to copy paste all of this code that I already did. Again, that doesn't sound like we should be doing that, right? And you're going to see another example where actually you have another problem why you don't want to be doing this. So if you already coded something, what do you do? And if it's a function especially, then you just call that function. We can do the same here. So let's look at these lines of code. Here we have 3 lines of code. And here we have 2 lines of code. So these that are exactly the same. So these 2 functions share all but this line of code. So instead of writing this here, you can just call this init function of the parent to finish off the work. Okay, so let's do that. What do I want? So here's a new piece of code that I'm adding, a new piece of data that I'm adding to my init function. And for everything else, I just want to call an init function of my parent to complete the job. All right. So that should be easy. Let's try to guess what the syntax is. I want to call which function? Init function. Okay. This one here, I want to call this init function. Okay, you call it functions, we call by names, you open parentheses and send any value that it needs. What does this function need? You need to give me a species and need to give me a language. Well, so the user, when they're creating this object, as a second and third a value, they're going to give me species and language, and that's captured in these two parameters. So I just passed these two pieces of data to Python's to a parent, right? To a parent's init function, because parent's init function needs it. Okay. Well, the parent init function also needs an object that you just created. So you may wonder, should I put a self here or not? Okay, so far init function, well, let's try something. Let's say we don't even know yes or no for that self. We are guessing the syntax. And maybe the guess is that, okay, you just go parent. So which init function? Because if you don't put any init function, it's going to look for init function in a bird class. It's going to find that one and run that one. So you're going to get here a loop calling itself all the time. But you want to call the one from the parent. So you tell Python parent. Okay, that's the one. Unfortunately, here's kind of an unfortunate piece of syntax in Python. You're not saying here parent. Here's the syntax. Instead of a parent, here's the word that you use. Super, open parentheses, close parentheses. Don't ask me why. I really don't understand why is this called like this. Makes no sense. Okay, so instead of saying parent, you say super, open parentheses, close parentheses. And it turns out that when you do this, you in fact are sending self as well. You're sending a reference to an object that you just created to the parent class, so you don't need a self here. Okay, it's just like a constructor call. You just send the actual pieces of data, not a reference to the object. That's it. So all this does is say run now. For the rest, run the init function of the parent. Okay, so let's run it. Let's see if it worked. So exactly the same syntax, except that we didn't repeat the code inside of an init function, and it seems to work. Let's see. Tweety bird length worked, tweety dot spec worked, tweety dot lang worked. Okay. So it worked. And how did it work? So Python, again, it sees a constructor, it goes to a bird class, looks for init function, it finds it. So it actually runs the body of this function. So the first thing this function does is assign to an object a variable beak length and gives it whatever we send it, which is 2.5. Okay, so that worked clearly. Then the next line of the code, you have a function call init, run the now init of the parent and send it what? Send it bird, so species, and send it chirp. So this function now starts running where species is a bird and language is chirp and finishes off the job. Okay, so that's it. You can just reuse the code. This actually has a name. What you're doing here is you are extending. This is called extending this function in it, right? So you are extending its functionality of the init function of a parent, right? So in this class, you just extend it. You just add something to it. And for the rest, you are calling the init function of a parent. So this is called extending. By the way, in terms of this syntax, you can actually do exactly what I was saying, which is you follow the classical call, which is you call init function. What does init function? Remember a classical call, you're really just calling it by a function name. Init function, that means you have to send itself. I need to send the address of my object that I just created. I need to send species, I need to send language. And where is that init function? Well, it's in class animal. So you just put this animal. So actually this, let's say, fancy piece of syntax gets translated into this. You're just really doing a simple function call to a parent. So that works too. Slef, oh, slef, this should be, this variable doesn't exist. Okay, but let's stick to convention, which is to use this, so this works as well, which is to use this super thing. I guess it does extra piece of work because it passes a reference to an object that we just created to the parent's init function. Okay, so that is how you extend a functionality of some parent function. So let's see what is the next thing I wanted to show you. Okay, so here's something else. So let's see, what did we say? If I do, yes, William.
I was just wondering, are you able to add one more parent function, like have two parent functions?
Yeah, that's a very good question, actually. And every year I get that question. Every class I get that question. But this year I forgot, and every year I have to check because I forget. But this year I forgot to check. In fact, I forgot to check in previous class and this class. I believe yes, if I remember right from last year. And every time I run a little experiment to see if it's possible, I believe yes. You can say, oh, let's inherit from animal and from, I don't know, point class. It doesn't make any sense. But then you have an issue because you're inheriting from two of them. If you have, let's say, I'm going to call a speak function. I don't have my own speak function, but ImageNet both animal and point have a speak function. Then is the question which one they're going to run. I believe it's the first one that you put in this list. But you can do this yourself. I mean, we can do it now. It's take 3 seconds. As I said, I just forgot, right? Class point. Let's just do, what did I say? Class point, let's just do, I don't know if this is going to work because I don't have an init function, but I don't want to spend time on that. Let's just have something like this. It should actually, hopefully, print, blah. Okay, so let's test this. Yeah. Let's test it. We create an object and now I do tweety.speak. All right, so it's running this one. But if I change the order, I'm a little bit worried what's going to happen with the init functions, but let's see. Yep, they still work. But I would assume now that it's going to type blah, that it's going to run the speak from the first parent. No, speak takes 0 position argument. Oh, yes, I have to do self here. Because actually it's sending, there you go. Okay, so you can always do this, you know, you can experiment your yourself, see what's happened. So yes, you can. I'm not sure when exactly does it make sense to have two parent. Well, I guess in everyday life we have two parent, but in programming sense, so you can have it, but then you may have a conflict. Then you have to think about if you have in both a function with the same name, which one that you have to put first, the one that you actually have, the one that is the one that you really want, the parent that you really want in such situation. Okay, so let's, all right. So I hope that answers your question.
It did, thank you.
All right, so William and Jason, can you put your hands down so I can see when there's new questions? All right, so let's continue. So since we were at speak, you have seen that when we create this object, function speak works. It prints, all right, tweety.speak. Python realized tweety's object of type bird, goes to a bird class, looks for a method speak. It doesn't find it, goes to a parent, finds it there, and runs that one. So we see it there. You may say, oh, okay, but this is not really what I want. In case of birds, well, then you can just completely rewrite it if you like. Here it is. You can go, right? What I want in case of birds is maybe to print self.lang, something like this. All right. So let's see that it works. So we create object of type bird. now when I do speak, when Python looks for a bird class, it actually finds it. So it's going to run this one. And what does it print? Well, this is 3 times the string. Which string? This chirp string. So it's going to print chirp, chirp, chirp. Okay. When we created the Snoopy object, that one, of course, is still of animal type. And when we did Snoopy.speak, that one was still right. This one will still print, I'm a dog and I bark. Okay. So how does Python, again, how does Python determine all of this? Is because it knows the type of object that a variable refers to. Tweety refers to object of type bird, so it goes first to bird. I didn't create Snoopy yet. I don't want to do that. I don't want to type too many things, but if we did this, from our previously run examples, it would tell us to Snoopy is an object of type animal here. So when you do speak, it's gonna go first to animal class and look for speak and run it. Okay, so in this case here, we completely changed the code of speak. So this is called overriding. So here, what we did with this function, when it also exists in a parrot, you overrode what it's doing, overriding. Okay, here we are overriding. Of course, you can have now a function that has nothing to do with completely new function that your parent doesn't have and it doesn't make sense in your function of, for example, report beak length. So here we may just return, let me make sure I'm spelling this correctly, return self dot. Okay, so here's a function that a parent doesn't have, but in case of bird objects, it makes sense. So then in case of bird objects, you can call that, function, or method actually. Oh, it doesn't take any arguments other than object itself, and then it works. And finally, you can do any of these, extending and overriding on any of these functions. It doesn't have to be an init function. Here's that other silly example. So for example, if we did Tweety print info, it doesn't find print info here. So it runs the one from the parent, but that one only displays the species and language. So you may say, okay, I want to change that too. So, but it already is printing, the parent is already printing the two. So we might as well keep that part. So we might as well do extending. You can just do print self dot, self dot beak length. That's a new piece of data that I want printed. But for the rest, I want to call a print info function from parent. And how do we do that? You use that magic word super with parentheses. Okay, so you call a super from a parent. So it means go to a parent and run this function from a parent. So we run that. And now, when I create Tweety object, and call print info, it prints all 3 pieces of data. So first it prints here 2.5, then it calls print info from a parent and prints species and language. So here again, we were extending the functionality of parents function. So that's basically all that I wanted to show you in this particular example. I would like to point out that, let's see, what do we have? We have Tweety. Let's do animal, dog, bark. That was Snoopy. All right, so let's see, remember if you do dir, Python tells you all attributes that a particular object has. For example, if we do Snoopy, it tells us, let's look at the Snoopy class. it tells us that there are two pieces of data associated with these objects, which is language and species. It tells us all the methods that we are coding: print info and speak. You see print info and you see speak. But in addition to the things that we recognize, you see now all of these underscore things. You now hopefully know that this is everything that you inherited from Python's object class. So you have, first of all, you have everything that you coded yourself and everything that you inherited from Python's object class. What is in Python object class? Well, you check it, object. Okay, so this is what you inherited from Python's object class. All of that is here. Some of it you changed behavior. So for example, init function, you inherited it from the parent, but in an animal class we wrote on. So we overrode the init of the parent. Also REPR, that's a representation thing. Remember, if you don't code it yourself, you inherit it from a parent and only the address will be displayed. So here we overrode the behavior of that function. So now you know what these things are, hopefully. So you have all the things that you inherited from your parent, plus all the things that you coded yourself that are not in the parent, like print info and speak. And here, for example, report beak length. So we can see that here, if you do dir Tweety, then in addition to everything, first of all, you see Tweety has everything inheriting from the object class. So these are all of these underscore things. It has three pieces of data. So it has a beak length, unlike the animal object. And then it also has a language and species. It has its own function, report beak length, and also speak that we overrode, but also print info that it inherited from animal parent. Okay, so now kind of that we are getting towards the end of the semester, hope finally you actually kind of know everything that what is listed when you're asking something about object or module. Okay, so let me show you one last example of something cool that you can do in Python. In fact, you cannot do it in other languages, at least not in Java, which you're going to do next semester. And it goes back to the first question we got in the beginning of the class. So say you're super happy with Python string class. So you have something like, oh, you know, okay, I want to create this object of type string. You know how to do it. That actually constructor is hidden behind calling opening parenthesis, opening quote, closing quote. In fact, calls Python constructor from a string class. And this creates an object, and then you can use now when you do dir str, now you know what these things are. These are all these things that you inherited from Python's object class, then the stuff that you coded yourself. We were using these mostly, or then the stuff that person who coded string class added. So some of the things are you could do as capitalize like this, and it capitalizes the first letter and so on. Many useful functions. But let's say for whatever application you're interested in, you really want to add the method that compares first and last character. So we have this string s, and you want to compare first and last character and return true if they're the same and false if they're not. It's a silly example, but I just want to show you the concept. So first, last, same, I want to do this and I want to get true. Of course, now you don't get that because such a function doesn't exist in Python string class. Okay, so then you say, all right, so what do I want? I really want everything from the string class. I'm super happy with it. I just want this one thing. You can do it. You just you can define your own objects that are like strings. You say, I want to inherit everything from string class, and I just want to add this one method. Let's try to do that. I'm going to design a class. I'm going to call it my own string. No, there's no parentheses here in this context. What do I say I want? I want So, and I want my string class to inherit everything from Python string class. We know the syntax for that. You open parentheses, close parentheses, and say, who do you want to inherit from? I want to inherit everything from a string class. Okay, you put the syntax like that. We've just learned that. And now you just add this method. Okay, so what do I want? So I have a function definition. We should start with def. As always, I am working with objects. I need an access to that object to compare first character and last character of that object, right? So I need self. But remember, I didn't code the constructor here. I didn't code anything. Not only I didn't code it, I don't even know where that code is. I couldn't even copy paste it. So this is actually a perfect example, in addition of not that it doesn't really make sense to copy paste huge pieces of code. In this particular code, I don't even know where is the code of Python string function. I would first have to find it in order to code it. And then, you know, how readable would it be? I copy everything and then add one tiny function. So here, I don't even know. It's complete black box. And I don't even, well, I wouldn't say I don't care. Maybe at some point I would care how they implement it. Anyways, the other case is this self gives me an access to an object, which is a string, because string class created it. Okay, so that means that I can index it. So I'm asking, is the first letter, and of course I should have a precondition here that this string has at least one character, otherwise this is going to crash if it's an empty string. I compare the first and last, but I don't want to compare the first and last. If they are the same, I return true, otherwise I return false. That's it. So let's see. What did I say? I'm going to have a string s created. It's going to be of type myString. Okay, so I create an object of this type. That object inherited everything from string class, including the representation. And what did I do here? str. Okay, so let's see. Did I run this? Okay, why is this? My str, I want to create a string and now, unlike before, this should not crash. What is happening here? Non-type object has no attribute first. What? Okay, somebody must be here seeing what I'm not seeing.
Professor?
Yes. Oh, return.
Yeah, it's class. It's so when on the first line.
Yes. Thank you. Class. I see something is wrong because even the representation should be inherited. REPR, we also inherit from the parent class. So when I did S, it should have showed the string. Thank you. So here I created an S. It really, we inherit everything. S.capitalize. We inherit everything from Python string class, but now this line is not going to crash. And by now you know why. Because Python realizes what is type of object is this? S is referring to an object of type myString. So it's going to look for this function first in a class myString. And if it doesn't find it, there goes to a parent. So for example, for capitalize, it doesn't find it, there goes to a parent, transitive parent, so everything works fine. Okay, so it works for this. And when we have two that are not the same, then T dot. All right, so why did this crash?
It's protocol object you defined a string.
Right, so let's look at type T. This is object of type string. We created it by calling string constructor, not my string constructor, right? So if you want this, if you want first last to work, of course you have to create object of type myString. and then it works, and it has everything in addition to this first last same function. So basically, this is all I want to show you about object. I'm lying a little bit because I'm going to say that objects, as I already mentioned, objects are mutable. And in terms of memory, they are behaving exactly the same as lists, for example. So we are not going to now repeat the same lecture about what's happening in memory with objects when they're behaving the same as lists. They're behaving as any other mutable objects, but I will, let me show you, put these three. Oh, I already opened them, I prepared that. These three codes, these three programs, little programs, all of them you should do by yourself. They are behaving exactly the same as lists. These are very similar examples of what we did with lists when we did memory questions, but you should be able for each three of these to answer. Of course, you can run this code, but you're completely defeating the purpose. You should open these and answer the questions for yourself. What does this print? If you don't answer correctly, it means that you don't understand how memory works on mutable objects and immutable objects, or both. Okay, so they are mutable objects, they behave like lists. Okay, that's all. We are done with objects. So for the rest of the class, I want to show you things that is about variables, that is related to memory. Before I do, are there any questions about what I just showed about objects? All right, so let's then go to things that are related to recursion. One of the things that is happening in recursion over and over again, that you're going to have many functions running at the same time, many, not just main and one function. So far, pretty much, when we run a visualizer, at most, you've seen main paused and another function running. When we get to recursion, you're going to have many functions. Jason, let's wait for the end. We're going to see many functions running at the same time. There's always only one function that is running. The other ones are running, meaning they're loaded in memory, but they're waiting. They're waiting for the one currently running to finish. Okay, and many of them have the variables that appear to have the same name. Okay, so you have to understand how that works in order to understand recursion. It's like a minimum requirement. So let's see. Although pretty much all of this you have seen already and used already, let's kind of spend a little bit more time to make sure that everybody understands. There will be one new thing there that you will see. So let me close this. And let's look at the first example. This one should be the most familiar to all of you because we've seen something like this all the time. But let's have everybody take 1 minute and answer for yourself. What do you think this prints? And I'm going to have a glass of water in the meantime. Okay, I hope you all have answered for yourself. Let's run it. There shouldn't be surprises here. Let's run it, and we see that what is printed here is 18 and A is 0. So in fact, the point is somehow to realize that this A is equal to 6 doesn't change this variable A here. So let's see this actually systematically. Before we look at the other two examples where it's going to be a bit of a new thing, let's first make sure that this is the one you understand, because actually it's this one that is happening all the time in the recursion. Okay, so let's understand what is going on here. Let me explain you how Python looks for variables. Okay, so visualize execution. Python learns there's a function called f, then it goes to the next line. So the next line lined up with the leftmost edge. Main is running, so global frame, main, the same thing. as always, when Python sees something like a is equal to 0, it has to figure out, remember in Python, you create variable by assigning value to it. So it has to figure out, should I create a new variable? Does variable a already exist? Let me put it that way. So the variable a, who is running? The main is running, the global frame is running. Variable a is not there, so Python creates a variable a. This is a global variable. Okay, it belongs to main, to global frame. It's created in the main. The variable name is lined up with the leftmost edge. It's a global variable. Everybody has access to it. We come to the next line. Inside of this print statement, we have a call to a function f. That means the global frame, the main, you can think of main as being a function as well. The main stops running, pauses, not stop, it pauses because it has to wait for this function f, because now f should run. Okay, so we jump to line 1, value 3 is sent to b. B is just a parameter. Parameter is just a variable, so local variable b gets created with 3 assigned to it. So it's the same as if we executed b is equal to 3. Okay, so therefore variable b that belongs to a local variable that belongs to a function f gets created. Here's what happens next. Python sees a is equal to 6. Needs to figure out, does this a already exist? Well, it does, but not in a local space, not in local function f. When Python looks for variable, if it's running a function, if it sees an assignment for Python, when it sees an assignment to a variable, it always means if this variable doesn't exist, I should create it. So Python looks for variable a in function f. It realizes a doesn't exist in function f. It doesn't look further, because that means for Python, she wants me, because local variable a doesn't exist, and she put that code inside of the function. That means that she wants me to create a local variable a that is assigned 6, and you will see that that's exactly happening. So a of the main stays 0, and f of also has a variable a. So this line here does not change the main a variable that belongs to the main. So in some ways, although it appears there are 2 variables called a, they are really, literally, physically, although it appears that we have kind of 1 variable, this is a and this is a, they are literally 2 variables referring to 2 different locations in memory. And you can think of it as the name of this one is a of f, so a belonging to function f, and this one is a of the main, a belonging to the main or the global frame. Okay, we come back here. Now return a times b. Then you do which a? You have to multiply a and b. There are 2 a's here. Well, a of the function running. F is running, so you're going to do a of that. So it's 6 times 3, that's 18. 18 is returned. So this function is going to terminate and return the control to the caller. It was the main that was calling and waiting line 8. So we 30 gets printed there since we waited for that. And now we print a, which a? Well, a of the function running, and main is running, so 0 gets printed. Okay, so that's what I want to show you about that. By the way, yeah, so imagine if we had something like this here, c is equal 10. I hope you realize that if I did print c here, that this line would crash, okay? This c is a local variable function. By the time you get to this line, this function doesn't even exist. It's not running. Let me quickly show you that. So main has variables f and a. So we come here, this function is running, okay, and it currently has this c, okay, which is 10, and we return as before value 18. This function is going to terminate. With it, c even disappears. It's not even there. And now you try to print c, and of course that's going to crash. Okay, that's first example. Here's next example. where I want you to ask yourself what's going to happen. Okay, answer for yourself. This is even shorter. What does this function print? This program, what does it print? Does it even print anything? Maybe it crashes. So take a minute, answer this for yourself. All right, let's run it. It doesn't crash. Oh, it does crash because I left something here. There is a leftover. Sorry, there's a leftover. It doesn't crash. That B thing shouldn't be there. Okay, so let's see why is this running the way it is. Oh, I want to go here. All right. Visualize execution. All right, next. Well, this is from the previous close. All right. Python learns this function call f, then goes to the next line, creates a global variable a, then it has a call to this function f, main pauses, f starts running, 3 is assigned to b, so local variable b is created, belongs to a function f. So here's where the thing is. We come here. We have a times b. We don't have an assignment. Nobody is assigning any. We are just reading value a. The question is, so what does Python do? It needs, of course, it looks for b, which b of the local function finds b. That's fine. 3 times what? So now the question is this going to crash? It's going to tell you a doesn't exist in function b, but you are just reading a. And it looks for a to read it. It looks for it in the local space of the function. It looks for it, a is not there. If you just want to read something and it doesn't find it in local space, it goes to a global frame, it goes to a main. That's why it's called global variable, all of these that you define in the main. It goes there and looks for that variable, looks there for the variable called a next. And it finds it there, and it's a 0. That's why it doesn't crash. So it does 3 times 0. That's a 0. So this function returns 0 to the caller. So the function terminate returns the control to the main. It returns 0 here. So 0 was printed, and you come to this line, and that one is obvious. You print 0. Okay. So last example. And it actually comes from looking back at this code. So if you think about this code, you may ask, but wait a minute, this creates a variable 6. But what I really want to do inside of this function, what I really want to do is I wanted to change this, this global variable. I didn't want you to create a local variable a with a value 6, and that Python is always going to do that when it finds an assignment inside of a function. And you say, but I don't want to do it. I really want to change the global variable. You can do it. And here's the piece of syntax. You just do global a. Okay, let me increase the font so you can see it. I want to just show you that this exists, but I'd be very happy if you forget ever that you exist, that you have seen this. I cannot come up with a good example to ever do something like this. The whole point, this breaks the whole point. First of all, let me demonstrate that this works. So that it indeed changes this global variable. It's changed the global variable to 6. I'm going to put it back to my code because I need to post this code for you guys. So what this does, it tells Python inside of this function, when I say A, when you see A, know that I'm referring to the global variable A. As I said, I would prefer if you never use it. I can't see a good reason to use it. In a way, it breaks the whole reason of existence of function. Function should be black boxes. You give it input and gives output. It shouldn't be that you just go in the middle of the function and do something there, okay? But that's, you can say that's philosophy, but it does break a philosophy of why you're using, why you're designing functions. Okay, that's all I want to show you. Luckily, this is not used in recursion. What is used in recursion is the first thing I was showing you, that the same variable name is going to repeatedly show up in various function calls. Okay, so in that, actually, I'm getting to my last and main thing that I wanted to show you for this class that leads us to recursion, and it's this example. Where is it? Yeah, it's this one here. Okay, so everybody answer for yourself, take, let's say 2 minutes, to answer for yourself, what does this print? Okay, let's see. Any answers?
Could I speak?
Yeah, you're already speaking.
All right,
Go
yeah,
ahead.
sure. 1 over, it prints out 1 over, oh, wait. Oh, it prints out 0. Yeah, it prints out 0.5 and then 2 and then 3 and then 4.
Exactly. So let's see
Okay.
why.
Yeah. Okay. I was about to say 1 over 2, but in
Okay. We see it now. So let's see why. In a previous lecture, I didn't really get correct answer, and I know that for many students this may be still a bit confusing. So it's actually critical to understand this. So because again, this is what's happening in the recursion all the time. All right. So let's run it. All right, so Python learns from these def, the 3 functions. Now it comes to this line, it creates a variable n that belongs, global variable n, whose value is 4. Then we see a first function call. So the main global frame pauses and function f of n starts running. What is n? N is 4. So f, this call is f of 4. So 4 is, so this red line is going to move to line 9, and value 4 will be sent to it. So this should be f of 4. What does Python do? Remember, the moment you start running a function, it does parameter is equal to argument. So each parameter is actually a local variable of function. So in this function, this parameter n, function f starts created, its own variable n gets assigned, its n is equal 4 gets executed because we've passed 4 here. So this function f has its own variable n, and it's 4. We now execute the body of that function, but the first thing that happens is that we have a call to function g. Okay, so function f is going to pause and function g needs to start running. G starts here in line 5. All right, but we need to pass, what do we pass to g? We pass value n minus 1. Which n? We have two n's. Well, in this case, we're lucky. There is, both are 4. So we are, 4 minus 1 is a 3. So we are passing 3 here. So g of 3 starts running. So we jump to line 5. So pause is going to, f is going to pause. It's going to become white. Function g starts running. We pass 3 to it, so n is equal 3 gets executed. So a local variable n, so each parameter becomes a local variable of function g. 3 is assigned to it. We start running body of that function. So that the first thing that happens, we have a call to function h. Okay, so therefore we're gonna, function g is gonna pause now, but function h is gonna start running. So we're gonna go to line 1. But we need to pass, here we are passing some value to the function h. What value is it? It's n minus 1. Which n? We have an n of the global frame, n of f, and n of g. The answer is always n of the function running, of the current function running. N of the current function running is 3. So this is 3 minus 2, that's a 2. So h of 2 starts running. This function pauses. We jump to function h. We passed it 2, so therefore n is equal to gets executed. That creates a local variable n for function h. So this function now, we are done with the first line. We execute the remaining lines. Print 1 over n. Which n? We have 1, 2, 3, 4 n's. N of the function running, which is h is running, its n is 2. So 1 over 2 is 0.5. So 0.5 gets printed. Then it says print n, which n? Well, still n of the function running. So we print 2. We come to the end of the, so here's something else. We come to the end of this function. So this function is going to terminate, disappear. It's done. But it returns the control to whoever called it. So who called h? Who called function h? You can answer, somebody.
G.
G, exactly. So you can see here, G in line 6 was waiting for h. So when h disappears, G is going to resume in this line. Well, it's done with this line. It's going to resume in line 7. But one other thing I would like to point out, the way this visualizer is made and the way you're going to do this for yourself when you want to do recursion, and we're going to do it in class, is the way you're drawing this, the function that called you is always right above you. So who called h? Well, above h is G. So G called h. So what happens when h disappears? G removes, it was resumes, it was waiting line 6, so it goes to line 7, it says print n. Which n? N of the function running. G is running, so it prints 3. Now G is going to terminate. It's done. It came to the last line, so it returns to its caller. It returns control to the function that called it. Who called G? Look above, f. Or here you can see function f, or you can remember, but here in this representation, you can find who called it. And there is a reason this is called stack. Here's your reason. This looks like a plates, stack of plates in cafeteria where you're taking one by one in particular order. Okay, so G terminates, returns the control to the caller. Caller was F. It was waiting in line 9, so now it can proceed to line 11. So it says print n, which n? N of the function running. That n is 4, so 4 gets printed. Now F, we are at the end of F. F returns the control to the caller. Who called F? Now look above. It was the main. It was this one here. So F terminates, returns the control to the caller. That was the last line, and the program is done. That's all I have for today.